This is another version of the water shader I was showing. The reflection is relative to wherever the surface of the water is. Your reflection actually distorts based on the water surface. In the previous version, it was simply creating a reflection by flipping the UV coordinates. This one flips the UV coordinates right at where the surface is. So if you have a tile somewhere and you've put this water shader on it, it will reflect just like this. In the previous version, it would reflect based on flipping the screen coordinates, which would not give you an accurate depiction of what should be reflected based on where the water is and how it's splashing. So this version is a little more accurate as far as that goes. This stuff here isn't a reflection, this is just the background. But the stuff here, as you can see closer to the surface, is actually reflecting what's above it. I have dissipate the reflection as it goes down, so it's only reflecting to a depth of 128 pixels. I added an ambient waving function to the shader also. So I made a few changes to the water draw. This is where it draws the water particles. Here I've pre-calculated the height of 1 pixel in the pixel shader, so it's 1 divided by the screen height, because everything ranges from 0 to 1. I disabled this highlighting information for now. I may need to figure out a different way to do that. It's using the y coordinate and multiplying it by the height of a pixel within the shader to get the shader's version of the surface y1 for the left hand top side of a column, and surface y2 is the right hand top of the column. And what I do is in the red value I store that. I store some of the lost precision, which is extracted here. The water drop, we don't care about the precision, it's handling the water drops differently. So if it's a water drop, meaning if it has a green value of greater than 0.9, because all the water drops are drawn with that color. It's sort of a hack to get around some problems with the water drops as they're rendered differently. In the future, I'd like to use individual masks for the water drops so that the mask can be used to calculate the exact surface position on the screen. This is the ambient waving of the water. We could increase this to make it more wavy, or to make the waves bigger. 0.01 is good for subtle. If I times this by 16, it'll be wavier. And if I want it even more subtle, maybe I'd use 4, which I probably would actually. If the UV coordinate is less than the top of the water, which is calculated here, and it's not a droplet, it sets the alpha to 0. If it's 0, then it just goes straight down to highlighting the droplets and shading shadows on the droplets. So it's doing some room lighting. If it's greater than 0.03, then we know it's the water itself. So the actual top of the water is extracted from the current red color of whatever pixel it's looking at, with this precision added if needed. It knows it's the water body itself if the alpha is greater than 0.03. The alpha is changed to 0, so it skips over that. And this is with regards to the mask, not the actual colors it's going to show. So it gets the distance to the top of the water from the current pixel. This value text height plus water top. I chose that all my water would be 128 pixels in height for all my water textures. Since the screen height is 768, this value here is sort of a normalized version of that distance. So here I have a variable I call true distance. All it's doing is it's figuring out how deep into the water it actually is based on the top of the water position and the pixel relative to the top of the water position. So it's getting the depth down into the water. I should actually call this depth because this calculates the depth into the water. I decided to do a distortion ahead of time for both the reflection and what's behind it. So this is extracting the image distortion of what's behind the water. This isn't actually the reflection. So this here distorts the x-coordinate closer to the surface of the water based on the horizontal distance from the center. I use this temporary variable here just so that I could put a cap on it without actually changing distance. And I chose for my water reflection section to be 128 pixels deep, which it then gets where that would be on the screen. If the UV coordinate is within that range, then it will do a reflection. It figures out the percentage deep into the water, uses that to figure out how transparent it's going to be. And what this does here is it's getting the reflected coordinate above the surface. So it would be top minus distance, but I'm multiplying it by 2 so that I can capture more of the scene reflected into that space. So it kind of squashes some of the reflection into that area, which, say I wanted to sample more, I could multiply it by 4 and it would get even more of the reflection. So it's taking all this right here and squishing it into here. If I don't multiply it by anything, then it's just an exact reflection of what's above it. I think it looks a little more natural if you're capturing more of the reflection within that sort of surface range. So I multiply it by 2. So then what we do is we multiply the level of transparency we'd like against the reflected sampled pixel, which we calculated the sampling coordinate here, and we add that to the background color that was sampled with the distortion applied based on how far down in the water it is. And the alpha is the inversion of the percentage down. If this one was say 0.8, this one would be 0.2. If this one was 0.4, this one would be 0.6. So then it's getting a percentage of each color based on depth. Caustics stuff is pretty much the same, except that I sped up the caustic motion a bit here. I decided that if it's a droplet, I would modify the color a bit. So yeah, it's not quite as... I don't think it's quite as nice as the original. It does what I want it to do. I think I can increase some of the precision a bit in the mask and smoothen things out a bit. And I could probably create a mask for the water droplets that would allow the shader to calculate reflections within the water droplets themselves. This is sort of just a proof of concept, and like I said, this is a work in progress.